A planet is in a distant solar system is 10 times more massive than Earth, and its radius is 10 times smaller. Given that escape velocity from the Earth is 11 kilometer per second, the escape velocity from the surface of planet would be. So we know the equation for escape velocity, that is equal to under root of 2gm divided by r. So we can write this escape velocity is directly proportional to the value of mass and inversely proportional to root of radius. So we can write the value of this escape velocity on Earth divided by escape velocity on that planet will be equal to under root of mass of Earth divided by mass of planet into under root of, we can take it as radius of that planet and radius of Earth. So we can write escape velocity on Earth by escape velocity on planet will be equal to under root of that mass of that planet is 10 times more than the mass of Earth. So we can take it as something but 10m, and it is given that the radius is 10 times smaller. So radius of Earth, if you are taking it as r, then it is r divided by 10, radius of that planet. So we can cancel this r and we can cancel this m. So this will be equal to under root of 1 by 10 and root of 10, which we can take it as something but 1 by root of 1 by 100, which we can take it as 1 by 10. So we can write escape velocity on that planet is 10 times of escape velocity on Earth, and escape velocity on Earth is 11. So 11 into 10, we can take it as 110 kilometer per second.